All right, good afternoon everybody. How are we doing? Everybody okay? And welcome to our SharePoint Search Decoupled session. My name's Steve Smith from Combined Knowledge, obviously not from around here as you can tell. And it's a great privilege to be here actually. It's my second time at TechEd New Zealand, and I have to say it's one of the best places I like coming to for doing conferences. It's always nice to be here. I am switching between machines right now, and I did actually have a bit of a nightmare scenario right now where I was just firing everything up, getting ready for this, and it decided to blue screen on me outside, and I'm just refiring it up. So I'm going to be running from the PowerPoints to start with, and whilst that's running, my machine's going to be getting the virtual machines ready for the demo later on in the session. So if you just see me kind of looking down here, quickly clicking something, that's all I'm doing, is refiring them up. So what we're doing is digging into a specific application service for this session, and the reason that I specifically picked the search session is out of all of the application services that SharePoint 2010 brought into the mix, the search is probably the one that has the biggest scalability that we weren't used to before from a 2007 environment. In terms of scaling in the amount of servers that we could apply it to, and also in terms of capacity planning and performance, being able to manage and control that environment a lot better. So I'll quick raise of hands, because that kind of gives me an idea of who's in the audience today. How many people in here, whether you've got 2007 or 2010 SharePoint, has got more than 4 SharePoint servers? Okay, not too many. How many of you have only got 1? Okay, and out of all of those people that only had 1, put your hands back up again if you're thinking of adding more servers in due course. Okay. Because this is always one of the things, isn't it, that we talk about with SharePoint, is the fact that we can get away with a single server environment, and ultimately when the time comes or the budget comes, we can add more servers in, and by that time hopefully we're using more of the functionality, and that then allows us to scale services across more servers so that we're not obviously draining all the capacity of a single box. Unless of course you've run the wizard when you've done an install. Then you've got all the services whether you wanted them or not, right? And so this is going to be all about what we do once we get the search one installed. So what are we going to cover? We're going to go through the search components, how the search service is actually carved up now. So when I talk about decoupling search, this is what we're looking at. What are the different pieces that make up the search service? We'll have a look at some common performance issues. Why do we even want to think about spanning search across multiple boxes? We'll have a quick checklist of some common issues that you find. We'll have a quick look at the topology overview. That once we look at those components, how do they fit into the SharePoint topology model? And then we'll have a look at some boundaries. Because despite the fact that we've got all these different components, there are reasons why we would want to scale those components as well and carve those up based on the amount of items that we may be choosing to index out of our various systems such as SharePoint file servers, etc. Then all being well, as long as my boxes decide to wake up, we're going to have a quick demo of configuring that topology and changing the way our search service is configured and is working. And then we'll finally, whilst we're waiting for the topology actions to be applied, we'll go through and look at some stress testing and performance numbers to give you a bit of an idea of why this is an important part of your planning. And I think that's a really important thing to think about here is we're talking about the search service here and looking at scaling and carving that particular service up. Of course, this is just one service. So the sort of things that we're talking about and approaching for this service can also apply to many of the other services that you can get in SharePoint 2010, such as your BI and your Performance Point and some of the other core services, that web analytics, that will require a lot of extra performance. So first and foremost, when we talk about the search service in SharePoint 2010, we kind of install it as a single service. You know, we go to service applications, new service, search service. And OK, it asks us to think about the crawl account that we're going to define with it. And then it also asks us if we want to have a couple of application pools, one for holding the admin role and another one for the query role. But within that server service itself, within that search service, we have several components. And for those of you that are coming from a 2007 background, you'll notice that these components are kind of a little bit different naming conventions than what you're used to from 7. So how many people in the audience have configured search in SharePoint 2007? OK. So for this instance, you're going to get a little bit confused by some of this because we've kind of twisted some bits. So for example, people often in 2007 used to say, OK, so which is your index server? Which is the server that's responsible for crawling the content from SharePoint or file shares or public folders, whatever? In SharePoint 2010, we refer to the crawler server role as the process, the service piece that's actually connecting to the back end and crawling those content sources. We have the query server role still, which is where the index partitions are living, which is when a user does a query, the content that they're receiving the query from is coming from the index partition. Now, what's changed from SharePoint 2007 and SharePoint 2010 is that the index partitions, these flat files, don't exist on the query role if your servers have been split up. So as the crawler component crawls the content in the content sources, the query server roles at the front end are where they are receiving the updates to their index file. So a slight topology shift there from 2007. We've got a search administration database, which is where SharePoint is storing things like the best bets and the security descriptors. We've got the property database, which is where we are, when we're crawling content from the search process and we're catching things like permission structures from NTFS files and from SharePoint permissions, and we're picking up metadata from the content that we're crawling. The property database is where all that information is being stored. And any of you from 2007 remember the property database in SQL started to grow very big, didn't it? Whereas before we were used to seeing the flat files growing quite large, but they still grew, but nowhere near compared to what they used to as a percentage. And that's because in SharePoint property database, that's where a lot of that information was now stored. So we kind of had a shift on where the storage needed to go. The crawl database, this is looking after the schedules when we're actually setting up the properties of a crawl, at what time it's going to crawl it, and the properties within the crawling process are stored in that crawl database. And finally, we can set a crawl target server, where we can actually say to the crawling components, every time you want to index content from a specific URL, for example, rather than go to any of the web front-end servers, I want you to just go to that specific web server and crawl the URLs from that. Some of you will remember that in 2007 when we had the little drop-down that said dedicate this server for crawling. Remember that one? And off it went. Anybody remember? Anybody in this audience remember when you set that to go and dedicate a crawler box, what did it actually do? When you updated the host file. And what happened if you deleted them from the host file manually? It put it straight back, didn't it? It was very confusing. And so what we recommended, and is still the case, is that you would go into the host file manually and specify the IP addresses of the servers. So rather than hit the actual production web front-end servers that were already being used by the users, we would be able to dedicate it to a box that wasn't in the production web front-end. And that could make a big difference in the performance if you were doing active crawling during a production time frame. So what are some of the common performance issues that we have today with search? Well, not just today with search, but common across the board. A lot of people don't realize that when we do search queries as a user, we're very much relying upon the available memory and hard disk access speeds and CPU to actually render the page results. And often when our web front-end servers are busy doing other things, and we've got some business intelligence running, some forms, whatever, and then somebody, or not just one person, several people concurrently try and do a query, that rendering of the query results can take time because of the page loading that's happening, because of other things that are happening on the box, not just the search query. So that's a very common issue. Of course, as we've already mentioned, in the components of the search architecture, there's a lot of those components on SQL. And so we've now got this situation where are we performing badly because of the resources on the front-end servers, or are we performing badly to the user because of issues with SQL resources at the back? And this has been a very common issue with SharePoint 2010, with the input of 64-bit front-end servers now having a lot more memory allocated to them. And we're doing the same thing we did in 2007, where maybe we're doing web traffic and query on the front-end server. We've now got 16 gig of memory on the front-end box, with obviously quad-core, probably CPU. All of a sudden, SQL at the back is receiving a lot more traffic than it used to in 2007. So we're finding our SQL servers very commonly becoming a bottleneck in the search architecture. And you know, you can easily test these things with capacity planning tools. And if you want to see more about this, I'm doing a session tomorrow morning where I'm actually going to run through a load test. And one of the load tests I'm going to run is how to do a search query against a user or multiple users going into a front-end server and querying for lots of different terms at the same time, and seeing the impact that that would have on the front-end server against the back-end server if, for example, we were doing an index at the same time. It can be a very common problem. Let's have a couple of others we've got. User profile service, access is slow for people queries. So again, here's the search service, which is somebody doing people search, but impacted directly by another application service, in this case the UPS. And I know Spence has already done the talk on the UPS. And because all of these application services have their own element of CPU and resources, you've got to think about that in your planning for search. Developers creating custom search result pages using custom JavaScript and CSS. So they've basically turned the search page, the search center for the users, into this lovely fandangled page that looks fantastic but performs terribly. Nothing to do with the search service. It's the code that's been laid on top of it that's impacting the user's perspective of how well it works. We've also got to consider the object models, such as the WCF communication timeouts between the services. And of course, there's the big one, which is communication between the servers themselves. And in fact, one other one that's in there that I should have added, really, when you think about it, is client computers. How many people in the audience that have been starting to implement SharePoint 2010 in your companies have found that the servers are performing great, but the minute you go and look at the user client machines that are, you know, sort of 5-6 years old, they're just not up to the job anymore of the modern applications? How many people have found that in their investigations? Yeah, it's a very common problem. So definitely one that should be looked at. Don't always blame the SharePoint boxes. Always look under the hood on the infrastructure as well. So there's an example of a search topology. You'll notice that I've structured mine very much in a 222 format. Obviously, because in the ideal world, we always have a second server in terms of resilience and performance offloading. And we can see that we've got on the lower base our SQL databases that are hosting our content databases, our property metadata database, property databases there, our search databases, and obviously our content databases for SharePoint. Of course, this is not assuming that this is all running off a single SQL instance. In reality, in a lot of medium, certainly medium to large SharePoint installations, you'll find that multiple SQL instances are required for the performance offload. And search is no different. One of the things that we get now with the decoupling of these components is that we can start having certain pieces of search hosted on different boxes. But not only can we have the search parts on different boxes, we can have the databases split up across different instances as well. That then allows us to obviously start thinking of our database alignment to spindles in the SANs and the disks, and make sure that we optimize the property database that's growing exponentially on very large environments. So I'm just going to get onto my box here. I'm just getting this thing started up, ready for when you do the demo. Just bear with me 2 seconds there. So on the middle tier, you can see I've put the application servers running the crawler component. Now, of course, we always assume that SQL is on a separate box, right, in the SharePoint world. We never assume that SQL and SharePoint, everything's on one box. Can you do it? Sure. Should you? No, not at all. So the query role at the front is assuming that this is a separate web server with the query role set up on it. The application servers in the middle tier are assuming that these are boxes dedicated to managing a service but not exposed to the user connection. Of course, if you do have one box that's running all of these things, certainly from a SharePoint roles perspective, you've got to be very wary of how many services you actually use and how much resources are available, because that's going to directly impact how many users you can support on that at any one time and what they can run. And search is definitely impacted by this. You'll notice I've also got that box to the side, the dedicated crawling server. So imagine that those 2 web front-end servers at the front are just running the web role, in other words, the rendering of pages for the user's sites and etc. And they're also running the query role, so that when a user runs a query, those index partitions are being hosted on the web front ends. But when I want to do an incremental crawl of the content, I want to be able to do that fast and efficient. In fact, I want to be able to do it very regularly during the day. What I don't want to do is when I run those crawling component actions every, say, hour, I don't want it hitting those production web front-end servers. So I can stand up another SharePoint server, and I can basically point the URLs using the IP in the hosts to that box. Of course, that's kind of nice, because if one of those web front-end servers fails, you could obviously bring that spare box into the front and become now part of the cluster, so you've obviously got a nice box that's standby ready to go in. So that's just how the topology would formulate in terms of the way it would look off of 3 tiers. So here's some boundaries to think about. And this is the bit where this decoupling of the search service is really important that you understand, because sometimes we might have to turn around and say, create another index partition on the front-end servers for no other reason than the fact we've reached the limit of one index partition on its own. So you can see that you could have up to 20 search service applications per farm. Okay, that's a lot of service applications in SharePoint. So, okay, you could do that. I'm not quite sure if you'll actually ever get to that point, but it could support 20. So each search service application can have 10 crawl databases per search service application. So when we were looking at those components, those crawl databases that's storing that information, we can only have 10 per search service. And each crawl database can have 25 million items. So now we've already reached a point, a threshold, where we say if we were looking at, say, 40 million items in our business, we know we need 2 crawl databases regardless. Because the threshold is already pointing us to the fact that we have to carve that component up and now split it into 2. Why are we doing this? Because we're trying to index 40 million items, obviously. And that's a lot of items, right? If we were to do it as one single crawl database and one single flat index file, it's going to take A, a long time, and B, when somebody's doing a query against that single index file, the bigger the index file, the index partition gets, the longer it's going to take to run concurrent queries against it. Because it's just going into this massive bucket of information and pulling the answer out. Whereas if you think about it, if we can carve up these components so that when we say, okay, when we reach 5 million items, we're going to carve that component up and create another instance of it. So it's got its own database or its own index partition. That way, when somebody does a query, we're not querying against this massive big entity that is everything. We're grouping the answers together from lots of smaller files, which is therefore going to be a lot quicker. It's also going to scale well, which means the minute we start getting up to thousands of concurrent users potentially on very large farms, it can support the growth of those users without majorly impacting the speed at which those pages are given back to the user when they do a search. But these components are not just beneficial for large enterprises. This scalability and the carving up of services can benefit everybody of every size. The big difference is we need more than one server to do it. So the index partitions, 20 per search service application. And remember, these index partitions will be living on those front-end servers. Indexed items, 100 million per search service application, 10 million per index partition. 10 million items per index partition. So even though we could do 25 million items for a crawl database, we're now having to have 3 indexed partitions to actually equate to the same number. You see how that now splits it up once more? So one of the important things that you've got to think about with these search boundaries when you're planning this is how many items you estimate are going to need to be indexed, because that's going to impact which components you need to create and host. Property databases, the ones that are hosting those metadata pieces, 10 per search service application. I'm just looking at some other random ones here. Alerts, 1 million per search application. I always find this quite amusing because most people don't actually ever use search alerts. Has anybody here ever got their users to use search-based alerts in SharePoint? So I think it's quite cool actually, because it's like we do it on Google, right? On Google you can set a search term and it will send you a notification if it finds new information on that term. You can do it in SharePoint 2010. Just be a little bit wary of trying to use this if you've got claims set up. Content sources, 50 per search service application. Content source being going to the content and indexing it and getting that crawl component to go and crawl it. And start addresses of each content source, 100 maximum. In other words, we can have a single content source that's going to 100 file shares, different file shares. Of course, that's not necessarily a good idea either, isn't it? On the same thing that we have to think about in terms of performance optimization for the users at the front end for the query, we also have to think about optimization at the back end tier when we're actually going off and crawling that content. If we try to put everything on one box and on one content source, you might end up with having a content source going to your file share, for example, and indexing terabytes of data under a single action. What you'd be better off doing is first understanding which of that content is actually being updated on a regular basis. And then have a content source that's dedicated to that type of content. And then look at the other content that might be archive read-only. Well, we don't need to index that again. That's a one-off index unless it gets corrupt and we have to do it again. So set that as a separate content source, index it over the weekend, and then leave it as it is. Of course, it does depend, of course, how many items are in that in the first place. So we must first work all this out so that we can fix our boundaries that allows us to then understand how we're going to carve those components up. So when we talk about scaling it, those component limits, those thresholds, are a very important part of why we may need to scale. But there are other reasons why we might want to scale search and start carving up those components. And the obvious one is resilience, right? We don't just scale for performance, we also scale for resilience. We've got one of our servers has gone down, the user's trying to do a query, they can't get the answers because the server that's got the index partition is no longer available. So we want to split the roles across. Now we already know, as we can see on this example here, that an index partition can have up to 10 million items. So if we've got to index anything between 10 and 20 million items in SharePoint 2010, we need to create a second index partition. So that means if we've got a single server, we will have 2 index partitions hosted on it. But I want resilience as well. So if I want resilience, I need to have a second server that's going to hold a copy or a live working copy of that index partition. So we have this capability in 2010, which I'm going to demonstrate shortly, which is being able to go into the topology and mirror that component to another server. So we can do it, obviously, across 2 boxes in this example. So I can create 2 index partitions, and each one could be mirrored to the other server that's providing that resilience. On the bottom of the slide, you'll notice we've got the crawl server, the servers that are going off and crawling the content to populate the index partition. You will notice that we've got 2 crawl databases that are, and property databases that are listed at the bottom in SQL. You'll notice that the 2 crawler servers cross-link to each database. So what we're showing here is that in order to get resilience of the crawl process, we've actually got 2 separate crawl servers which are actually crawling the same content in essence, but pointing to the same database to store it. Because the databases are king here. These are the key to it all working. Everything's stored in the databases. So if one server goes down, SharePoint can just flick it to the other service, which is also hosting the crawl action for that content. So having the ability to carve up each of these tiers in search makes it a fantastic capability for both resilience and for performance now. And it means that if you've got enterprise environments or just large storage environments, you don't have to be a big company to have a lot of data, right? I've been to a few small companies that have got much more data everywhere. In fact, I remember one company that had about 40 folders called stuff. Come on, how many people in this room have got a folder called stuff? Put your hands up. Honest? Yeah, okay. Now, times you by 300 people in your company. Now, the next stage to that scalability and the failover piece is that previously on the other side, I was showing you this mirrored capability. I have mirrored this index component 1 to the second server. So I have 2 live index partitions, which means if a user goes to either one of those 2 servers, the query will be answered by the relevant index partition. But what if I wanted to have resilience and failover, but failing over from one of those front-end servers dying? So you can see here I've introduced a 3rd front-end server. But that doesn't host any of the index partitions from a live perspective. It's not mirrored to be a working version. It's mirrored, but it's going to be set to failover. In other words, it will only be used if it cannot access one of those live index partitions. So this is a very powerful capability that we've now got, which is when we carve the components up, we can define whether it's a live mirror or whether it's a failover mirror component. So why don't we have a look and see what that looks like? He says. I bet I need to change my screen resolution, do I? Oh, no, that should be all right. Am I on number 2? Any reason why we're not flicking over?
1280, 720. I have no idea then. Have you seen this?
Let's try it again. Let's try and flick it over. No. Let me try it again. I'll try it from this one. There you go. Fine. Yeah, great. Thank you.
Might want to make sure this one's 1280.
Yeah, they are, yeah. All right, so let's go into our central admin here. And as we can see, I've got a few services on this little farm. And that's not from the wizard. I've got a search service here that's a group search. And currently, this is all set up as a single server environment for SharePoint. So I've got one SharePoint server, separate SQL component, and the two new SharePoint servers that I've just introduced, I've finally got them into the farm as part of my budget. So I've got two new SharePoint front-end servers. And what I want to do is I want to take the current topology of everything on one single search application server and move them out. And we have this little topology option here in the search application topology. If I click on that, it's going to take me to this page where not only can I see what current servers are allocated which of those components, but I can also go into those specific components, get a little drop-down arrow, and I can say, you know what, I want to change or edit or add to that particular component. And so that's all very nice. It allows me to take what I've currently got and change the properties. But what's really powerful about the search service in 2010 is the fact that I can go in and actually create new versions of those components and dedicate them to doing a specific function or component role or indexing specific content. It's using the crawl process. Which, as we've already discovered, if I've got more than 10 million items, I would need to create a new index partition to host that extra content. You'll also find that when I create that in a minute, that it actually works in reverse order. So rather than create the top one first, you can't actually create the second one until you've created the third one, because they use each other as they get created. And we'll see that in a second. But let's do the first thing. Let's start with the start. Let's have a look at what we've got here. So we can see here that SQL Corp is hosting all three databases. It's hosting admin, crawl, and property databases for the default content. And it's got those lovely names associated with it. And that's obviously because they've just been created using the UI mechanism for the service. There's my crawl. Component 0 is what it calls it by default. There's my admin component and there's my query component. So currently, crawl component 0 is on SharePoint 1. So SharePoint 1 is the server that is going off and crawling any of the content sources that I've defined. SharePoint 1 is also, at this time, the role that is hosting the index partition so that when a user does a query, it's SharePoint 1 that's going to answer that query. But I'm going to change that because I've got SharePoint 2 and 3 now, and they are our front-end servers that are load balanced. So I can go in and edit the properties of this role. Because I've got two new servers in my SharePoint farm, it pulls them in and says, you know what, you can choose a different server now to host that role. So I can say, okay, SharePoint 2. It then says, okay, which is the metadata property database that you want to align to this role, this component. So if I, for example, had created several property databases in SQL, and I created a new query component role, I can point it to its own specific metadata database that's got content from, for example, the file share. I can also define the location of that index partition file, the one that grows fairly large and runs out of your C drive space fairly quickly. That's where we can see where that's going to go. But notice also, not only am I moving this role there, it's also giving me the option at the bottom to set it as a failover only. So rather than it be the live component, it's just there in case the live one dies. Well, of course, I've only got one at the minute, so I don't want to be ticking that. So I'll click OK. It's not actually done anything. All it's done is gone into the topology builder and gone, OK, you've made some changes, but you've actually not made any changes yet until you do apply topology changes. But I'm going to do that in a minute because it takes a few minutes. So we want to do it all en masse. So we're going to wait for a minute before we do that. So now I've got SharePoint 2 configured. I've also got SharePoint 3 though, and I now need to make the decision. Do I want the other SharePoint web front-end server to host a working copy of that index partition, which basically means whichever server the user goes to on the front end, the query result will build from either of them? Or do I want it to be a failover so that it only gets used when SharePoint 2 is not available? So I'm going to go back to this component, and I'm going to go back down to this drop-down, and I'm going to add a mirror this time. And this is basically saying which other server is going to host a copy of that index partition. So again, I get my choices. So this time I can select SharePoint 3. But notice the property database mapping has now grayed out, because it already knows what it's using, because the previous one was defining which property database to use. This is not being a brand new index partition. This is just being another copy of it on the other box. We can change the location of the index file, but you don't really want to be doing that. You should be having consistent locations for each one. I could choose it as a failover, which obviously means that this one would only then get used if SharePoint 2 was not available. But I'm not going to do that because it doesn't make sense in this instance, because I've got SharePoints 2 and 3 as live front-end servers. So we can now see that our query component 2 and 3 is pending updates to be created. So what about adding some more of these? What about if we actually wanted to support the ability for multiple items? So let's say I'm going to create a new crawling location, and we need to store more than 10 million items, so therefore we're going to need another property database, another flat file index, or 25 million items in that case. I can now go in and create a new property database here, specify my SQL instance, which does not have to be the same SQL instance as before, and define a database name that is going to be using for hosting that crawl content. So whatever we want to decide to call it, for this instance I'll just call it SP crawl 2. Word to the wise, that failover server, I don't know if any of you know this, if you do, forgive me, but for those of you who don't know, the failover server option here is used by SharePoint when you've got mirroring with a witness server set up. So you can't just put another database name in there. That is for environments where you've got a SQL mirroring environment set up, hosting your databases, and the witness server will auto failover to the second node in SQL. So unless you've got a witness service mirroring instance, you can't define anything in here, so you must leave it blank. So we create the database. Of course, we've not created anything yet. We need to wait till we apply topology changes to go and create the database. But it's there. We can see it. Property database, SP crawl 2. Now I can go and create another index partition, because we're going to be hosting more than 10 million items. So it says, who's going to host this index partition? Well, it's not going to be SharePoint 1, because SharePoint 1 is my back-end crawler server role. It's going to be back to one of those web front-end servers again, like we saw on the previous slide. So SharePoint 2, and it's going to align to that property database 2. Now we can see the alignment of those components taking place. OK, that. And now we've got our new property component database there. And we can now obviously go into that component. So here's our SP crawl 2. We've got our single component, and we can now do that mirror option again, so that we can host it now across both servers again. So put it on SharePoint 3. Not a failover. I want this as live, right? And there we go. So we've now added that second index partition. So now we're looking good for those sort of 18 million items that we were talking about. You know, we can cover that growth of index items. The obviously ability now is that it's saying that we can now start looking at creating additional components, such as the crawl database, for storing all of those content source listings, etc. So from a performance perspective, it tends to be much larger environments where you've got a lot of index locations that you're going to crawl, adding a second crawl database when you're doing very aggressive crawling would be a very useful part of taking the load from a single crawling server, or not so much a server, but more a database logic. Imagine you're trying to crawl a single database and everything's going into one database. We want to split those components off, so I want to be crawling some of the content that goes into that crawl database. So rather than have hundreds and hundreds of items in one database for crawling, telling it where to go and what time and schedules, we split that over two databases as well. So instead of having a single server trying to handle all that process load, we can split the instances across. And this enables us to run a lot more concurrent processes at one time through the search service. So we could just, for example, create a SP-crawl2 component. Now you notice at the bottom it says here, do you want to dedicate this crawl store to host the specified host distribution rules? The host distribution rule is the ability, after we've created this, to go into SharePoint and say, when you go to a specific location, a specific URL, use this crawling database to store that information from this server only. So it allows me to actually align the crawl database to a specific destination only on one host node to point to it. The problem is, if you did want to do that, you must tick that dedicated option here, because if you don't get the option after it's created. So if I tick that box there, it will give me the ability for that crawl database to be available after I've created it in Search Admin as a host distribution option. And you have to have more than one crawl database for it to be there. So we can see the components are slowly but surely building up. We're starting to separate them out a bit. And this is obviously a really important part of scaling those large enterprise or middle tier environments of millions and millions of items. And so this is a crawl component. So this is the component that's actually going to crawl the content. So this is the server that's going to act as going to go to a particular content at the back. And so on this instance, I'm going to pick it back to SharePoint 1. I don't want it to go onto the front-end servers. I want this to go back to my middle-tier servers that are going to be doing some of the grunt work when they go back and index that content. And so notice now that we can again associate this crawler component with a specific crawl database to store that metadata that it's going off and, all the URLs that it's associating that it's going to. So we can specify now that this new crawler component aligns to that new crawl database that we just created. And again, where do we want those temporary flat files to be? That temporary index store as it crawls the content to go on the file system. Always on C by default, remember that. Always on C. Unless you specified somewhere else, that's where it's going to go. So now we've created those various components. And as you can see from here, we've got all pending creation actions against them. So once I click that Apply Topology Changes, it's going to go to all the specific servers that are in this topology change. If the search service is not started, it will start it. Search is one of those services where when you actually configure a component to be installed on that particular server, it will go into the server services and initiate the server service to start. It's a shame it doesn't do that on all of them, isn't it? Where we have to go in and start doing that manually. What's a good example of a service that you have to go in and manually start it? It won't do it for you. Yep, use profile service, manually start that, don't we? Yep, it won't do that for us. Sorry? Oh, the one that, you mean in IIS? I've never seen that always turned off. The time, yeah. Yeah, I mean, I was more thinking of the application services, like manage metadata as well, for example. So, but yeah, use profile service again. You have to manually start that, right? So I'm going to apply this. and I'm not holding myself to a time on this, because it might take a while before we finish. Hopefully before the time I finish it, how long have I got left? Don't say now. A few minutes, right? We've got a few minutes. We'll let that carry on. Maybe it'll be nice and play so we can go and see the changes that it's affected. But to all intents and purposes, that's the process that we're trying to achieve. Carving up that service, defining the roles, splitting them up, and then having the search service now manage those new components for us, allowing us to have that scalability and resilience as we scale up and index more items. Whilst that's doing that, here's just a few little numbers for you. Obviously, you guys get access to the decks and stuff afterwards, right? So you can always come back and look at these later. But I just wanted to just finish off with some few numbers. So here was an example of a 16 gig memory on all the boxes. Of course, this changes when you start to have multiple web front-end servers with 16 gig on 64-bit platform and SQL's left on 16-bit. The more servers we have on 16 gig memory doing SharePoint and only having a SQL box on 16 gig could be a big performance issue. And we talk about that tomorrow in the capacity planning one. Notice that the item level we've got here is 9 million items. 9 million, so just under that 10 million index partition size. Size of the crawling database, 52 gig. That was in this instance, right? This particular example. 11 gig on the log file in SQL. 68 gig on the property metadata database. 1 gig log file on that. 2 gig search admin database. And a 38 gig index partition. So you can see here that the difference between the index partition and that metadata database was almost half. So a lot of people think, oh, I'll scale this out because it's going to get really big on the query server role, which is holding that index partition. No, it's the database that's the one that's growing much larger than that index partition on the front-end server. So think about that now. 9 million items, 38 gig on the index partition. If you did not carve this service out, if you had 30 million items, you could end up with 120 gig index file. When somebody does a query, it has to search that whole data store to get that access to that information before it goes back to the user. Better to have 3 30 gig databases files to get that information from. It's going to do it a lot quicker than a large 120 gig one. We know that in everyday life, don't we, when we do a defrag of our drives. The bigger it is, the longer it takes. It seems to get exponentially longer the bigger we do it. Just a quick example here. This is taken from the search capacity planning papers that you can get off TechNet. There's some really useful information on there. Okay, some of it's a bit out of date. They're updating them fairly regularly. There was an update on some of these capacity planning docs a few months ago. But it does kind of show you the impact that can be applied when you start thinking about concurrency of our users. So here's an example where we're doing, on the top one, we've got 7 million and 9 million items. And we can see that as the user load goes up of concurrency, the latency, the seconds it takes to return the results to the user. If we start looking at the 20 user load, where, I don't know if we've got a laser thingy on this, have we? Oh yeah, there we go. So if we start looking about here on this left-hand side, up to 20 concurrent users, you're in sub 1 second returns. Which is, and again, don't forget, 20 concurrent users in the real world, you're probably looking at 10% concurrency on average, unless you're using a lot of social networking stuff, which can go up a little bit then. But, you know, 200 users could quite easily be aligned to 20, for example, as concurrency. But the minute you start going up into your 60, 80 concurrency, we can see that we're kind of creeping up on that long latency return to the user. And this is the point that some users might start to complain, right? So if we look on the bottom one there, same thing. You go to 1020, throughput, queries per second. We handle about 20. The minute we go beyond that, Very little gain. How would we get more gain from that? What would be the way that we could counter that from what we've just discovered? Anybody? We could scale out our query servers. What else? Another index partition. Right, because we're kind of borderline, aren't we? 9 million items, we could well be borderline. What if we split those roles up? We could then counter that and give more concurrency because it's split across 2 roles. We could have just 2 servers, but split the index partition role up to give us that better concurrency and results. Of course, anything with search still involves memory and CPU. The more we do, the bigger we get, the more resources we need to handle it. And that's just one service, in this case, search. But it is, without a shadow of a doubt, in my opinion, one of the most developed services in SharePoint 2010 to give us the ability to do that carving up process as we've just seen, right? Because it allows us to take each and every component and then scale it out, which is perfect. I know I'm over, so I'm going to call it a day there. There's obviously lots of SharePoint stuff going on. Where are we? Thursday. I keep forgetting what day it is since I'm here. Oh, we still got 10 minutes. Right. Okay, well, we've got plenty of time to keep going. So we're going to do a quick Q&A in a minute anyway, and I've got a couple of prizes to give away because I know I get told off if I don't. But yes, there is various content in the SharePoint stack, but specifically about the stress testing and the capacity and concurrency stuff that I've mentioned. If you want to learn a bit more about how to test that, I'm doing a session tomorrow morning in the Crown Plaza, which is specifically about how to build load tests so that you can actually use Visual Studio to do those scenarios and say, well, what if we did this? What if we tried to do it and we've only got a server with X amount of memory or X amount of partitions, and then we try and scale it out, or we have a server crash. What's the impact of that? See, it's all very well and good having the ability to carve these components out for a single service, but you've still got to understand what the impact will be on your other services, on your other servers when you do this, whether it's at the front end or the back end. We've just talked about the ability to see where search, even though we can move and modify our topology, which, lo and behold, has gone and configured itself, although the crawling component still seems to be refreshing. But we can see here we've now got our SharePoint 2 and 3 now very much involved in the topology of the search process. And those 2 front-end servers, which is the ones that my users will go to now when they do a search query in their search page, now has a copy of that index partition on each one. SharePoint 1 is no longer hosting that role, so that will no longer answer queries from the users. So it's a very, very powerful scalability piece. There's always the question that then lingers, though, isn't there? If this can do such scalability, do we really need something like fast? Of course, they're 2 totally different products, right? Fast is a completely different beast. But even though this service can carve itself up, and we talk about an index partition of 10 million items, there still comes a point in the performance cycle of SharePoint search where you might get to 30 million items, and it still becomes a performance or a server issue where you just need too many servers to do the job. And the requirements of the business lend itself to fast anyway. Just because you can go up to 100 million items in SharePoint and carve this service up to host it doesn't mean you should, right? In fact, even going over 50 million items even with this service, and this service can handle 50 million items, but at the end of the day, the minute you start going beyond that into very large repositories, you really do need to start thinking about fast, because it's really the option that you need to go to. SharePoint is not really going to be the answer at that point. So don't rule it out. But then don't think it's the same as this either. Different skills, different technology, it's a very different world. But that's not to say that we shouldn't be thinking of using this in our current models. If you've got a situation where you've got a single SharePoint server, which I know some of you did, and you're going to start adding multiple servers to your farm topology, start thinking about how you're going to scale your search components out. Decouple those components, move them, and make them resilient or fail over, depending on how many servers you've got available. And don't forget that each of the components can be carved out, including the databases at the back end, hosted on different instances if required. So think of that size and scalability. We saw that example, didn't we? 68 gig. Where is that going to be hosted on your SAN or your spindles? Because it's going to be thrashed. It's going to be hit hard. Okay, so we've got about 3 minutes left, I reckon. So we'll open the floor up. Has anybody got any quick questions that we can cover in 3 minutes before we carry on? But I have got 2 prizes, and actually the 2 chaps that are going to win the prizes are the 2 gentlemen that answers the question. So this chap here and this gentleman here, if you would like to come forward, I've got a little prize for both of you. Is Steve here anyway? Steve, you in here still? I thought he was going to come out and tell me off for not there. There you go. One for you. One for you. Enjoy. I really like that mouse. I didn't actually get told off for it. He was handing them out to the speakers, and I didn't realise that I had to hand them out. I was like, oh, cool. I said, I hope it's a UK mouse. It's a UK keyboard, sorry. And he went, no. And then he gave me another mouse. I went, I only need one. No, you've got to give them away. I was most upset. So just to point this out, we didn't get one. I don't know what gives with that. Anyway, so anybody got a question they want to ask at this point? Anybody got a question about what we just did?
Is this sort of the reverse where you shouldn't be scaling out until things are at a certain level?
In a capacity planning perspective, yeah, absolutely. Don't over-engineer the problem, right? Don't just start creating multiple index partitions and databases just for the sake of it. As we saw in that example of performance at 6-7 million items, that's a lot. And I would bet most companies are a long way off from 7 million items. And most companies might be around 2 or 3 million. You don't need to scale unnecessarily. I would tend to look more at the resilience in those instances than creating lots of unnecessary data. But one of the things that is interesting is sometimes we have to scale and carve it, not because of search, but maybe because of other services that are eating up the resources, and you just need to move some components out of the way. And because we can do it with search and we can't do it with some of the others, we're kind of left with no choice in those scenarios. How often can you go into a business and start talking about, well, if I could just have another server? They said, no. So you end up going through that process, don't you? Unnecessarily, you're kind of having to scale out. But the answer is no. I definitely wouldn't start creating all these different components unnecessarily. I would much rather go down the route of having 2 web front-end servers and a middle server, 2 middle-tier servers, and using those properly first and optimizing those than unnecessarily scaling it. Yeah, so you don't always have to just go, woo, let's grow lots of databases. Yes? Well, that's the beauty of it being the database logic, because everything relies on the databases. So databases are king in this example. So it's not reliant upon the fact you've got 3 servers. It's the fact that those databases are key in the restore process. One thing you've got to be wary of when you're doing a restore is the alignment between that index partition and the databases. So if they get out of sync, you end up having to recrawl your content anyway, because they just don't recover properly to each other, and we've seen that before. So, obviously, when you do the backup process, you should get both pieces. But if you don't, and one of them's not backed up at the same time, and you end up with this differentiation between the 2 components, when they try to lock together again, you can end up with the fact that it just won't align, and you just end up having to do a full recrawl. But an interesting point about backup and restore, though, is if we end up having such large index partitions anyway, the question then becomes, we should really be figuring out how long it would take to restore it, because it might well turn out to be quicker to just re-index the darn stuff at the weekend anyway, unless we've worked out our content sources well. Because if your content sources are designed well, you can have your critical data re-indexed very quickly. The not so critical stuff could be recrawled in the evening, and the read-only stuff that's in the archive you recrawl over the weekend. So you set up that kind of expectations of which content we want to get back quickly. When you've done that analysis, you suddenly realize, why restore it? Why not just recrawl the critical data? We can actually get that back quicker than it would take to restore the databases from the backup. Worth thinking about. You need to test both scenarios. But that's where carving up the components can help you, is in a DR scenario, because you can quickly get one back if you've carved the components up. That makes sense? Okay, I think we're on course. Yes, we have to stop. Anyway, I hope you found that useful, guys and ladies, and thanks for coming.